EDX Mechanics 1, Impulse and Momentum. Momentum. In a collision between two objects, we assume that there are no external forces acting on the two objects, and we consider a quantity called momentum. This is a property of the particles which depends on each of the masses and their velocities. And the definition of momentum is mass times velocity. Momentum is a vector quantity and it's measured in Newton seconds. And we often measure an object's change in momentum. So we often talk about the change in momentum of an object is its final momentum, take away its initial momentum. And an important note about momentum, it is not a measure of energy. You must not confuse momentum with kinetic energy. They are different quantities measuring different things. Example 1. Find the magnitude of the momentum of a speedboat of mass 180 kilograms moving at 80 meters per second and a steamroller of mass 3.6 tons moving at 4 meters per second. So let's look at the speedboat first. We know momentum is mass times velocity. So the mass of this object is 180 kilograms and it's moving at 80 meters per second, which gives it 14,400 Newton seconds of momentum. If we look at the steamroller, that's 3.6 tons, so that's 3,600 kilograms times 4 meters per second, and that also gives us 14,400 Newton seconds. So the interesting thing here is that we've got a light, very fast speedboat, and it has the same momentum as an enormous mass steamroller moving at a very low speed. So although they have the same momentum, they do not have the same kinetic energy as each other. Find the change in momentum of a body of mass 3 kilograms when its speed increases from 6 meters per second to 15 meters per second. Bearing in mind that momentum is a vector quantity, you are strongly advised to draw diagrams to show what's happening. So we've got our 3 kilogram mass. You don't need to put forces on here, just 3 kilogram mass will do. It initially was going at 6 meters per second, so I'll just put a little note there that that's before the change, and then afterwards underneath the diagram it's moving at 15 meters per second, and I'll just put a little note there after. So it's a nice simple convention is to put the velocities before the change above and the velocities after the change below. So the initial momentum. And it's fairly obvious here that we're going to take the right as positive. Okay, it would make perfect sense. So the initial momentum is the mass 3 times its velocity to the right 6. So the initial momentum is 18 Newton seconds. And the final momentum, and again it makes sense to take right as positive in this simple situation, is mass 3 and its velocity to the right is definitely 15 from the diagram, is 45 Newton seconds, and therefore the change in momentum is the final momentum, which was 45, take away the initial momentum, which was 18, which gives us a change of momentum of plus 27 Newton seconds. So you'd expect a positive change of momentum since the speed has gone from 66 up to 15 meters per second. And you can see the method there. Need to be a little bit more careful in this question because it's going to end up going in the opposite direction. So find the change in momentum of a 3 kilogram mass when its speed changes from 5 meters per second to 4 meters per second in the opposite direction. And this is where a diagram becomes even more important. So we've got a 3 kilogram mass. Before anything happened, it was going at 5 meters per second, and after the change it was moving in the opposite direction. Make sure the arrow is pointing backwards at 4 meters per second. So let's have a look at the initial momentum. And it makes sense in this question. I'm going to take the right as positive because that seems more straightforward. So my initial momentum to the right is mass 3 and the velocity to the right is definitely plus 5. So that's 15 Newton seconds. If we now look at the final momentum after the change, and again I'm going to take right as positive for consistency and simplicity. We've got a mass 3, but if we look carefully now, if right is positive, but this object is going backwards afterwards at a velocity of 4 meters per second, then I need to call the velocity minus 4. So the final momentum is minus 12 Newton seconds, and therefore the change in momentum, which is what we were looking for, is the final momentum, and the final momentum was negative 12. Take away the initial momentum was 15, therefore the change in momentum was minus 27 Newton seconds, i.e. a loss of 27 Newton seconds. So because we took right as positive, the change in momentum in this question was a negative 27 Newton seconds. In the next session, we're going to be looking at impulse.